Hey, Mr. Dow here again. Today we're going to talk about section 7.2, sample proportions. We know that P is your population proportion. That's a parameter that's describing everyone in the entire population. P hat comes from a sample proportion, and that is a statistic that we're going to gain information on the parameter. We're going to take a sample in order to make some observations and statements regarding the entire population. Here's an example. To find P hat in this situation, I have 2,010 people in approval out of 3,000, so I can say that P hat 2010 out of 3,000 is 67% are in approval of the president. That is estimating or representing the entire population proportion P. Well, how well does that actually estimate? Back in the last section, we found out these things. Well, what do I know for fact? I mean, is it actually fact that as the standard deviation gets smaller, my sample size will have to get larger? Well, let's find out. If I were to take a simple random sample of size whatever, let's call it n, from a large population that has some population proportion denoted by the letter P, with a characteristic of interest. P hat is going to be the proportion of the sample having that characteristic. The following items are going to be true. The sampling distribution of P hat is basically going to be normal, or close enough to normal, when the sample size is large. And of course, the larger the sample size, the more normal the distribution of P hat. When I say sampling distribution, I mean collecting multiple samples and then graphing them. The bigger the sample size, the more normal that curve will look when I make that distribution, which is the collection of all of P hats. The mean of that sample distribution will be P. That's the average of all of my P hats. And standard deviation is given by the following formula. This is the standard deviation for a sample proportion. There's a few rules that I have to follow to be able to use the practice of collecting a sample to represent the population. Rule 1. Your population has to be 10 times or at least 10 times the sample size in order to be able to use the formula for standard deviation. Rule 2. If I'm going to use normal approximations, aka z-scores, the two following things have to hold true. N times P has to be greater than 10, and n times 1 minus P has to be greater than or equal to 10. These rules are checking to make sure that your sample size is big enough, but at the same time, not too big. What I mean by that, if you can take a sample size so large that you may as well just be more advantageous to do a census. So I'm checking for undercoverage and making sure that the sample size is not too small at the same time. I want to have that sweet spot of having just the right size sample. And that really is it for section 7.2. Now in your textbook there's a great example on page 438 where they're talking about using z-scores just to go back and refresh from earlier chapters. You should probably give that a look. Again, that's page 438. It's the entire example saying going to college, and it's using normal calculations involving P hat. I would give that a look, and then we'll have some problems to look at when I see you next.